Right, here I've got the water tank, which obviously collects rainwater from the roof, and it's used for things like flushing the toilet, doing the laundry, and a couple of the outdoor taps. Now what I'm going to try and do is fit an ultrasonic sensor here to determine the water level here, so I know how much water's in the tank. So I'll see how we go with that. Here on the other side, I've just got the water pump here, which kicks in when I use water from the tank, so flushing the toilet or doing the laundry or watering the yard from one of those taps. Alright, so when I went looking for an ultrasonic transducer, the first thing that came up online on eBay was these things here. And these seem to be pretty common everywhere. Okay, lots of people are using them. It's got transmitter, receiver, and the 4 pins. Now the one I'm actually going to use, because I also found it, was this all-in-one unit. Now this is very similar to what you have on the car bumper bar there, so you know you can see proximity when you're parking. So that's the one I'm going to use because it'll be neater at the top of the water tank. Now the code for this, I found someone else, of course, has already done it on a Raspberry Pi, so I'll link that video so you can check his info out on how to hook it up. But what I will do briefly is just show you a bit more about the voltage divider circuit that he talks about, just to make sure you understand why that's there. If we have a look at this close up, you can see the model HCSR04, and you see the 4 pins. We've got VCC, trigger, echo, and ground. Now VCC is just the 5 volt. This is a 5 volt device, so just give it 5 volts, and ground is ground. Now the trigger can run off 3.3 volts, like you get on the GPIO pins of the Raspberry Pi. But the echo that comes back from this, which will go into the Raspberry Pi, is 5 volts. Now the Raspberry Pi can't handle 5 volts in on its GPIO, so I'm just going to make a voltage divider circuit, and I'll just go through how that works now. Now as I said, this is a 5 volt device, so the echo pin that feeds back into the GPIO pin on the Raspberry Pi will start off as 5 volts, and we can't go feeding that into the GPIO pins. So what we're going to do is just design a voltage divider circuit that will make that 5 volts divide across a couple of resistors, so we can pluck the 3 volts off the middle of it and feed that into the GPIO pin. And here's the circuit I'm going to use. You've got 5 volts on the top and 0 at the bottom, and because I've got 2 resistors, that 5 volts will be split up between them. But these aren't exactly the same values. You've got a bigger one here and a smaller one here, so it'll be slightly more than the 2.5 that we had before in my example. So there's a formula for this, which I'll probably link to in the info if you really want to work it out yourself. But this is what I'm going to use. That'll give me 3 volts from the center here, and it's enough resistance to stop, you know, a massive current flow going straight through the thing. So that's what I'm going to use from the echo pin of the transducer. Right, here's my test unit. I'm just using some 5 volts from the Raspberry Pi to power this thing, and a couple of the GPIOs for the signals. And you can see I've roughly set it out how I had it on the board there. So the yellow here is the 5 volts that comes back from the transducer, and it starts at the top. And between this resistor and that resistor, because that one's ground at the other end, it'll divide it, and then we'll get the 3 volt signal and feed that into the Raspberry Pi. I'm going to make a neat connector using this ribbon cable here and put the resistors on there and use some of these connectors here to go to the actual transducer, so it'll all be nice and neat. Alright, here's the finished product, and I've just plugged it in and got a bit of a program running to demo it and test it out. Now, I'm not going to go through the code, but I'll put a link in the guy's video where I got the code from and just modified it to suit my needs. But the point is, you can see that it works. So if I put it, I don't know, about there, see the distance, about 300 mil. Obviously, as I get closer to the bench, the number gets smaller. So that's good. Point it up there, there you go, 800 odd mil. So that's good, that works. Now, as I said, I'm not going to use this particular one. I'm going to just swap that out for this one. Okay. So now, I have the easy to use little ultrasonic sensor. Okay, so we're going to do the same kind of thing. There it is. Same deal. Alright, so that's going to go in the top of the tank and hopefully reflect nicely off the surface of the water inside, and I'll be able to work out the water level in the tank. So here it all is, the Raspberry Pi powered from PoE with the connector there to plug into the GPIO pins, and I've just got the voltage divider circuit as part of these cables here. That goes into the 4 connectors on the ultrasonic sensor, and that just leaves me with the transducer itself to fit to the tank. Right, I'm going to leave it there for this video, but I'll make a part 2 when I go to do the actual physical install of the transducer into the water tank. For now, I just wanted to show you the concept of what I'm up to, and once I figure out how I'm actually going to do this install, I'll put up another video then. So until then, take it easy and I'll catch you next time.